Hi, I am Rashani DeBell, and you are learning algebra. Hi everyone. Today we're going to learn how to solve a system of equations using graphs. So let's get started. What is a system of linear equations? A system of equations is a collection of two or more equations. For each system, there is the same number of variables as there are equations. So in my example over here, we have two linear equations, 5x plus 4y equals negative 12, and 3x minus 4y equals negative 20. In this set of equations, you can see that I have two unknown variables, x and y. A solution to a system of equations is an x and y value where the graphs of the equations intersect. My solution to this system of equations is x equals 3, y equals 6. This is where the two equations intersect. The steps to solving a linear system using graphs is to first write it in slope-intercept form, y equals mx plus b. Then draw both equations on the same graph. Estimate where the two lines intersect. Finally, check the solution by substituting the x and y values into the original equations. Let's go ahead and try a few problems. Here's our first example. The question asks us to solve the linear system graphically and check the solution algebraically. We have two equations. We have 5x plus 4y equals negative 12 and 3x minus 4y equals negative 20. Remember, our solution to our system of linear equations is where the two graphs intersect. In order to find where they intersect, our first thing is to graph the equations by writing each equation in slope-intercept form, which is y equals mx plus b. So I'm going to start with the first equation, 5x plus 4y equals negative 12. I'm going to subtract 5x on both sides. I'm left with positive 4y is equal to negative 5x minus 12. Isolate my y by dividing everything by 4 and simplifying the resulting equation. 4 divided by 4 is 1. 1 times y is just y. I cannot simplify the negative 5/4, so it's just going to remain negative 5/4 x. Negative 12 divided by 4 is negative 3. This means that my slope, m, of this equation is a negative 5 over 4, where my rise is 5 and my run is 4, and I have a negative slope. My y-intercept, b, is at negative 3. This is where I'm going to start my graph, at y equals negative 3. Here's my y-axis. I'm going to go all the way down to negative 3 right over here. And this is where I start my graph, going down 5 since it's a negative slope. 1, 2, 3, 4, 5, and over 4. Going to create a line that goes up 2, so we're going to go starting at negative 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm going to continue this line. 1, 2, 3, 4, 5. 1, 2, 3, 4. By continuing the line, I can make sure that I get a good enough graph to see where my points intersect. So now I'm going to work on my second equation, the 3x minus 4y equals negative 20, and write that in slope-intercept form. Step 1, subtract 3x on both sides. What I'm left with is negative 4y is equal to Negative 20 and negative 3x are not like terms, so I cannot combine them. So I have negative 3x minus 20. Isolate your y by dividing everything by negative 4 and simplifying the resulting equation. Negative 4 divided by negative 4 is 1. 1 times y is y. Negative divided by a negative is a positive, 3/4 x. Negative 20 divided by negative 4 is a positive 5. This means that my slope is at positive 3/4, which is a rise of 3 and a run of 4. It's a positive slope, meaning it goes up from left to right. And my y-intercept, where I start my graph, is at positive 5. Looking over here, positive 5 is right here. It's a rise of 3, 1, 2, 3, and run of 4, 1, 2, 3, 4. Going to follow this, going down, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Connect my dots. And there we have it. Here is our graph of our linear system. Now remember, the solution to this graph is where the two lines intersect. And looking at this graph, it looks like it intersects right over there. And this point is at x equals negative 4 and y equals 2. X equals negative 4, y equals 2. I'm now going to check my solution to make sure that this is the solution for the system. In order for this to be the solution, it has to make both equations a true statement when you substitute in negative 4 for x and 2 for y. So I'm going to check the first one. 5 times negative 4 plus 4 times 2, does that equal negative 12? 5 times negative 4 is negative 20. Positive 4 times 2 is positive 8. They're different signs, so I'm going to subtract and keep the sign of the bigger number, and I get negative 12, which is equal to negative 12. And so it's a solution for the first equation. Let us see if negative 4 and positive 2 are solutions to the second equation. I've got 3 times negative 4 minus 4 times 2. Does that equal negative 20? 3 times negative 4 is negative 12. Negative 4 times 2 is negative 8. They're the same sign, so I add and keep negative 12 plus a negative 8 is a negative 20, which is equal to negative 20, and there you have it. Our solution to this system of linear equations is negative 4 and 2. I now want you to try a problem on your own. I want you to solve the following problem by yourself. Try it and come back to me, and we will work through this together. So here's our second example. As you can see, the first equation is already written in slope-intercept form. So all we have to do over here is identify our slope, which is m is negative 2 over 1. There's a rise of 2, run of 1, and it's a negative slope. My y-intercept b is at negative 3. This is where I'm going to start my graph, at y equals negative 3. Going to go all the way down to negative 3. Start graph over there. Rise of 2, and since it's a negative, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, continuing up, following the pattern, up 2 over 1, up 2 over 1, 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 and let's connect the dots. Here's our graph of y equals negative 2x minus 3. Now for our second equation, we need to write this in slope-intercept form before we can graph it. Remember, slope-intercept form is y equals mx plus b. So start by subtracting 2x on both sides. I have positive 5y is equal to negative 2x plus 25. Isolate your y by dividing everything by 5 and simplifying the resulting equation. 5 divided by 5 is 1. 1 times y is y. Negative 2 over 5 x, and positive 25 divided by 5 is positive 5. So my slope is a negative 2 over 5. Again, rise of 2, run of 5. There's my negative slope, and I'm going to start my graph at y equals positive 5, which is right over there. Since this is a negative slope, I'm going to go down 2 over 5, 1, 2, 3, 4, 5, down 2 over 5. I'm going to continue the pattern and go up 2 over 5, 1, 2, 3, 4, 5, up 2 over 5, and just connect the dots. And there's my graph of 2x plus 5y equals 25. Now, our solution is where these two lines intersect. And it looks like right over here. This is at x equals negative 5 and y equals 7. So let's go ahead and check to see if this is our solution by plugging negative 5 in for x and 7 in for y into our original equations. So I have 7. Is that equal to negative 2 times negative 5 minus 3? Negative 2 minus 5 times negative 5 is positive 10. Minus 3 gives me a positive 7, and yes, 7 is equal to 7, so it checks on the first equation. Let's check the second one. 2 times negative 5 plus 5 times 7, does that give me a positive 25? 2 times negative 5 is negative 10. Positive 5 times 7 is positive 35. They're different signs, so I subtract and keep the sign of the bigger number, which gives me a positive 25, and positive 25 is equal to positive 25, and so this works, and therefore our solution to this system of equations is x equals negative 5 and y equals 7. And there you have it. That's how we solve a system of linear equations using graphs.